is what we know. If you're coming over, I just wanna be real with somebody like me. If I tell you how I'm feeling, would you say that you want me? Cause I'm so sick of all the noise, all the back and forth. Just wanna find a still place where I could go. I lose myself, I cannot help it, I'm emotional. Oh, if you feel like this, would you let me know? Would you let me know? Please let me know. Would you let me know? Oh, if you feel like this, would you let me know? Would you let me know?
Ladies and gentlemen, please join me in welcoming to the stage your MCs for Day 1 Reactathon, Ryan Burgess and Mars Julian.
Thank you. So there was a change of plans. Mars is not here today, but she will be here tomorrow, which is great. Mars and Jem will both be there. I'm Ryan. I am your MC for tonight. I lead a podcast called Front End Happy Hour. Mars and Jem are both panelists on that. So we're very excited to be here at Reactathon. Who else is very excited? Yeah! This is such a cool venue, too. I feel a little weird, like, speaking in it, but it's very cool. So I'm excited to be here. Happy to see everyone that's come out. It's good. We have some really great talks I'm really excited for. Also want to shout out to our sponsors. There's some amazing sponsors, the major sponsor being Clerk. Without sponsors, I mean, we probably wouldn't have the conference. So it's great to have so many great sponsors helping us put this on together. So let's do a little bit of housekeeping too, just to get level set and get everyone prepared for the conference. There was a couple items that we wanted to talk through. We do have a code of conduct. You can find that on the website. So if you are wanting to check that out, feel free. It is available online. We also are running the Pac-Man rule. Who has heard of that before? Okay. Good. Not as many hands. That's good, because I had no clue up until about 10 minutes ago what that was. So I'm going to explain it. I like it now that I've learned, but it is the idea that if you're standing around in groups talking, leave room for people to join you and have conversations. It's always great to get to know folks. The whole Pac-Man is, the open, leave it open for people to join you. So if you now you know, because I did not know this either. We also have Wednesday's lunch. There is a custom map available online. Check out, and also there is a Slack group if you would like to join and connect with people for the Reactathon Slack. We have amazing speakers tonight, like I had mentioned. Lots of great speakers tomorrow as well. But tonight we have quite a few, and Theo Brown will be the first keynote tonight. So we will be welcoming him to the stage. Come on up. Welcome, Theo. I'll let him get set up. Theo, I feel like some of you may have seen him on various YouTube channels, videos, as well as, I liked your bio, shit posting on Twitter. That's a fair point? Or on the online?
Educational shit posting.
Educational. Also, are we allowed to be swearing in a synagogue? I'm not sure, but I just set the tone. Yeah, all right.
Looks good to me.
All right.
Cool. I'll take it from here. Thank you very much. Let's get started. So, I want to talk today about React, the past, present, and future, and most importantly, how the future of React is us, the community. React is built around strong primitives. I think we all know that. It's both the beauty and also in a lot of ways the biggest weakness of React. It's by design very primitive. We have these pieces that we can build and assemble and do incredible things with. But with that comes lots of problems and challenges. And I think it's fair to say that React asks a lot from us as individual developers. We need to understand what it does and doesn't do and build solutions around the things it doesn't so we can build great applications with React's primitives at the core. The primitives weren't always there, though. This has been a generational effort full of generational shifts. And I like to think of the history of React and the relationship with React to the community through these generational shifts in the moments that are centered around specific primitives as they were introduced. The obvious first one is components. With components, for the first time ever, we could reasonably compartmentalize parts of our UI in reusable fashion. And I'm not saying React invented components. I'm just saying React normalized them in a way that we started to really adopt them and see strong traction in applications. We even saw people using third-party packages that bundled and worked with components, such as Material UI, which came out in 2014 originally, as well as things like Storybook, really leaning into this component model and the idea that our components were a thing that we could assemble and reuse even between applications and as packages people could install in their applications themselves. This idea was so powerful that I think it was key to that initial adoption of React. The framework itself was great, but when more and more things around these primitives started to form, and we had tools that were exciting beyond React itself, that's when I think adoption, and more importantly, excitement, really started to happen. But with this generation and with these incredible primitives came some growing pains. The biggest one was Redux. Not Redux specifically, to be very clear, but the reality of state being a complex problem in a componentized model. And the primitives that React provided for this were too localized to the components to really be scalable and work well for a wider set of applications. It was tough to think about state in one way and have it work for most apps. And as a result, pretty much every app I used in this generation and every code base I worked with used a different set of things with their own different opinions on how they should be used. And it became a bit of a spaghetti nightmare. And I think React understood this, and they listened, and they paid close attention to the community and worked with us, which is why we saw such a huge shift with hooks. The value of hooks wasn't just, oh, you can write your state in an easier way. It was deeper than that. State now had its own level of composability, its own primitives. For the first time, you could npm install state, not just components. And that's when we saw things like React Query in Motion happen. Framework Motion in particular, the first commit was 2 days after hooks were officially announced. And it was really cool to see people have this click moment of, oh, the state being separate from the component means I can ship you state, the concept, and the life cycle around it, and we now, as the developers consuming these things, can build on top of these ideas. When you have good primitives at the core, you can build better, slightly less primitive things around them, and us as the developers who build applications with these things can do really incredible things. But that doesn't mean all was solved. I think we all know that. Otherwise, we'd be out of jobs and AI would be handling it for us. So what were the growing pains here? I'd make the argument that the big remaining one was the server. And we've absolutely seen that in the past, present, and future. I am going to make the argument that both of these frameworks, Next and Gatsby, were the growing pains here. And I'm even going to argue that Next was a little bit worse here because it looked like they were building good primitives. Get server-side props seemed like a good extension of what you could do with React, where you now have an entry point that runs with server, and then it hydrates this information throughout your application. But it's not really how React works, because there was a strong boundary between the top of your app and your server-side properties, as well as a weird control flow of when the request hits the server, when does the response actually make it to your components, or does it at all? That lack of clear method of actually watching your data go through your app made it so Next was more a pile of hacks on top of it, rather than a true React framework. And that was scary. As I became a bigger Next fan over the years, what I found was my best Next experience were actually not using Next. It was using Next as a host for my React application and a method for serving server-side endpoints that had better patterns, not necessarily perfect, but better enough that I felt like I was maintaining building a maintainable application. But the patterns it introduced were incredibly painful, which is why we're lucky that they decided to throw almost all of that away. Turns out, servers are kind of hard, and in a way that was new to the React team. Previously, the problems that React solved were problems that existed in their side of Meta. Meta had real UI application problems, real experience, interactivity, and just general, how do we ship a good app? Those problems, I'm not saying they weren't hard too, but they were hard in a different way, mostly in a way that was at a certain point in the application boundary onwards. So it was not necessarily the right place, team, or mindset to build good server solutions. And I think that's why it took so long. Server components happened to a lot of people would argue server components happened really late. Most other frameworks had a solution for this much earlier in their journeys. But I think React needed to better understand the server problems and let us go through the hell of server standards, which you can sit here and convince me all day there is no such thing as fetch on server. You cannot override that which does not exist. As such, I think we're in a really cool, unique moment here where after years of iteration on these things and years of playing with what React on a server looks like, I think we're figuring it out now. And the React team's done a great job of working with us to do that. Server components are going to need a lot of our help as this happens. Unlike hooks, you can't just adopt server components. You can't say, OK, I'm on this team at my company that has hundreds of engineers working on our web app. We're building this new feature. We're going to use server components from here down in our existing React tree. This allowed for me personally to push hooks really hard at Twitch when they first happened. I was able to say, OK, this is the pattern that the ecosystem's moving in. These are the tools that we want to use that primarily support and work with hooks. If we want to make the best and most maintainable applications going forward, we should seriously consider and adopt these new patterns. That is much harder with server components because the entry point's different. We just don't own or if you have an entry point that existed already, be it you're generating a static web page or you're using Express or you're using some other custom server technologies, you can't incrementally adopt server components the same way. On top of that, they're asking a lot more from us because now as developers of libraries that are building solutions in React, you're no longer just thinking about how these things work on client or even how they work on client plus one server-side pass. You now have to worry about this relationship between the server and the client. As much as this is for us to swallow and as much more work as the maintainers and builders of these libraries are going to have to do, I think that's what got us here in the first place. The strength of the React community comes from these primitives, both what they have and, more importantly, what they're missing, and the relationship that this inherently builds between the React library and framework and team, as well as the community and the library builders who build into it. And we're working really hard to make this future happen. I was hesitant to put this in, but I got bullied by a lot of people. We're working really hard to build one example of this. Tools like S3 just aren't ready for a server component future. So yesterday, we launched Upload Thing, a new tool to make it easier for full-stack devs to do file uploads, because the way that it worked before was considerate of the server side exclusively. And there was other tools that were considered of the client side exclusively. And what server components enables is for us to build patterns that don't just understand server and client, they understand and define a relationship between the two. We have to think a lot more about what we're building when we do this, and React does too. I think that's the really important part that I wanted to push now, is that the React team has to and has chosen to learn from us. In order for React to keep growing and keep innovating in the ways that it's so well known for, it has to understand us even better. If you're the type of person that shows up at an event like this because you care enough to come to a place that's titled Reactathon, you probably understand the problems, solutions, and experience of developing in React better than most. And as crazy as this might sound, why haven't you reached out? Why haven't you hit up the React team to talk about your experience with it? I'm sure we've all seen a thread with Dan on Twitter back and forth, but there's more people, and they want to listen. I know that. I chat with them regularly, and they care so much. And that's why this is happening the way it is, and that's why the solutions they are producing have continued to wow us and push us forward in this ecosystem. It's a back and forth constantly, where an idea is had, a primitive is made, the community embraces it, uses it, tries it, finds limitations, a long back and forth ensues, a better primitive is built for that specific problem, the same thing happens, and now we're in it the third time with server components. And they're asking more from us than they ever have before. We have to think more about how our bundlers behave and how they code split between the server and the client. We have to think about use server and use client, and one of those terms doesn't mean what it says it means. We have to think about the relationships between all of these things in a way we haven't before. But the result when it works is a level of composability and honestly just an ability to move fast with code you're confident in that I've personally never had before. And that's the bet React is making. They are betting on us to do the hard part, which is convince our tech leads, convince our companies, convince our friends even, that it's worth making this bet and coming along for this crazy ride. Because it's going to be crazier than the previous ones, where obviously porting from Angular or an old PHP app to React was hard. Adding hooks wasn't too hard. Moving entirely over to it obviously was, but if you had a component you wanted to use new patterns, you could. Server components are asking for much more buy-in. And not just from us, from other framework maintainers too. Like, I don't think we understand the relationship between Next and React as much. I don't want to tangent too long on this, but that closeness isn't happening because Vercel's this big evil company trying to take over the web. It's happening because the people on React that wanted to push it towards the server and take advantage of what they were hearing from the community realized the best place to do that wasn't necessarily Meta. And we're all going to be in similar places there too, where maybe the team we're on at our company is the UI or like design team. It's going to be really hard to sell server components from those positions. But that's the challenge they're posing to us. We're no longer just front-end developers. We're building infrastructure. We're building backends. We're building services. We're building APIs. We're building database technologies. Next.js, and with it now, server components, has almost tricked me going back into my backend roots, because I've been in front-end land now for as long as I can remember, like 5+ years, mostly doing front-end. But these tools make it so much fun to compose these primitives and to treat these parts of your server, your database, your API, and all these layers, just treating them like you would any other component. It's really freeing in a way. And it's going to be a battle for us to convince others of it. But React's always been along the ride for the ride with us in this way. They've given us the tools and the resources and the people and the time that we needed to make these things happen. From silly things like Dan talking on Twitter to more important ones like the working group that is now finally formed so that the React core team can directly interact with the people consuming these things. They understand that this gap is big and arguably getting bigger every day. But that's also what makes it React. These primitives are so strong that the surface area that they can innovate in and cover is just massive. I often joke now that for as wide as React is, React Native is 10 times deeper, because that community does crazy things to make React work in places I never would have thought of. But that's the magic of React. It lets you do things you've never thought of. So now it's our job to make people think about them. And it's not going to be easy. We're going to be talking to a lot of engineers that are convinced your backend has to run Golang or Rust, or it's not really a backend. You're going to talk to a lot of people who have an existing solution that aren't convinced moving to these new ones will help at all. You're even going to have library maintainers who don't want to put in the extra effort and are just going to port their stuff to work in Solid or Svelte anyway, or instead. I think we need to push harder, and I think we need to bet on this as well. The only way server components succeeds is if we're bought into, more than ever before. Hooks could have worked some amount without us, but server components can't. So much so that React itself went to work with Next to get it as far as it is now. More than ever before, React is relying on us. It isn't just betting on the server, it's betting on the community and our ability and our love of what these frameworks and what these tools enable. They're betting on us to prove to people that this is worth it. And I'm really confident that we can do it. I'm so proud of the work that all these teams have been putting in. They've been doing incredible things, and I think the future is bright. And I hope we take the time to really test out, play with, and understand what these primitives enable so that we can not just understand them ourselves, but we can widen the room, and we can, next year, have a Reactathon that is 10 times bigger because all of a sudden all the backend engineers are here too. So think to yourselves, who are the people that might not be ready for this? Who are the people who might not even want this? Why not? What can we do to better understand them? What can we do to solve the problems that they have? And how can we work together to build a better web for everybody? I think server components will be a part of that better web. But the only way that will happen is if we all make it happen. So who's with me? We going to do this? Server components going to happen? That's what I was hoping to hear. That's all I have. Thank you guys so much. Really appreciate it. Thank you. Thank you.
To the conference. Theo, nice job. I mean, React is really all about community, so I definitely agree with a lot of those points. And I've seen React used in some pretty amazing ways. I work at Netflix, and actually the TV is all done in React. Like things like that, I've seen it pushed to all the limits, which is really cool. So thank you, Theo, for bringing us along that journey. Next up, we actually have our second keynote speaker. Colin's going to be talking about how to build a component worth 1,000 APIs. So I think that's a good second keynote following from Theo. So Colin, you want to join us? Hey.
Can you guys hear me? Yes, cool. I think Theo went 8 minutes short there. The master of the 3-hour YouTube tutorial. Cool. So my name's Colin. I'm talking about two things today. First, the idea of a component being worth 1,000 APIs, and then second, kind of how to come up with components that can be worth 1,000 APIs. I guess the underlying thread here is the evolution of third-party tools. I'm going to step away from this, just pace a little bit. Yeah, so it's going to be a good talk. I'm Colin on Twitter, Tweets by Colin. My company is ClerkDev. More relevant to this talk, though, I'm the co-founder of Clerk, and we build components as a service for authentication. And so that's an example of our sign-in component. And more importantly, I think we started as an API for auth, and nobody wanted it. And so this was all about, or I think this is kind of like our evolution as a company too, figuring out what can we deliver to actually give something to developers that they want to use for authentication. So starting things out, a brief history. So before APIs as we know them today, if you have not dealt with the beloved SOAP API, consider yourselves lucky. These are from circa before Stripe, and they looked like this. So what you had to do as a developer was you'd import net HTTP, you'd kind of craft the HTTP request yourself, and then they would send you back this XML body. From there, it was your responsibility to bring in an XML parser and go attribute by attribute and figure out what was going on. I don't want to knock these things too hard, right? This screenshot is actually from a company called Sabre. That's a global distribution service. It really powered the online travel agency revolution. So it was a really big deal. But I think, in that case, the travel agency was really the customer and less so the developer. And what we have today, today's gold standard in APIs, is more, first of all, it's REST APIs, but that almost doesn't matter. It's SDKs. And so this is an example from Stripe's documentation. It's a JavaScript snippet. And, I can tell you that under the hood, it's form encoding up and JSON down, but that doesn't really matter. What matters is this is my experience using it, and it's native to what I do as a developer in JavaScript. And of course, they have API or SDKs for every language, right? Not just Node in this case. So this is really the gold standard. And I think when we started Clerk, the first thing, Clerk, by the way, is we've been around since 2019. Very long journey to here. This is what we started with, right? We wanted to be Stripe for auth. And we copied everything down to the form encoding up, which, as it turns out, is a terrible idea. A year after we made that decision, we reached out to the Stripe people, and they're like, we did this because it looked prettier in the docs, and it doesn't work because you lose the magic of null that you can send up in a JSON body. Yeah, so anyway, form encoding, bad idea. You don't want to do that. Don't just copy Stripe. It doesn't necessarily work for you today. You kind of have to go back down to first principles. And where we landed is that today, the component is the next gold standard developer tool. The business case for this, as we see it at Clerk today, why do Clerk's customers love us? First is the most simple, right? It's back-end and front-end in one tidy package. API, back-end only. Bring in the UI, it's back-end and front-end, right? That's kind of how we positioned ourselves early on. We get to move, or developers get to move faster just because we're doing more for you. Second thing, a little less obvious, but it's better design. And this is a tweet, one of my favorite tweets about Clerk. My sign-in page is going to be the best designed part of my app. We have a very unfair advantage as Clerk where we have full-time designers that only care about the sign-up flow and making it super high conversion. Chances are in-house, you don't have that, especially in the early days, or really even into a team of hundreds. You don't end up getting a proper identity team until you're thousands, tens of thousands of employees. And so yeah, as a component as a service company, we really lean into this. There's lots of subtle animations and just stuff that you wouldn't normally do in-house. The last one I think is actually the most important, and I don't think we really understood this until much later on in our life cycle. The biggest benefit of components as a service are really just building a developer tool so that a front-end developer can consume them, is that it unlocks the front-end developer. So if you think of our predecessors in auth, building an API, it's a back-end developer that consumes it, but the job isn't done on the back end. They need to do some plumbing, get the data down to the front end. The front end has to make the UI. And you end up with this, the back end is constantly blocking anything the front end wants to do, and it's very frustrating. And what we have in auth, or in Clerk today, is the front end team is completely unlocked. They don't need to contact the back end team for anything. And then the backend team, it's actually this win-win. The backend team just doesn't have to think about auth, and they really don't want to think about auth. And so, this was a surprising like sum greater than its parts kind of thing, like the acceleration that you get just by unlocking the front-end developer is really impressive. So that's the business case. I said at the top that we're going to go through two parts in this presentation, both the idea, so that was the idea, and now we're going into like actually executing. How can we come up with components as a service to build? I really think that like this front-end cloud ecosystem, staring at like Lee, this front-end cloud ecosystem, like we're going to see hundreds of components as a service kind of crop up as more people just adopt this pattern, right? And just like 10 years ago, we saw kind of a new API every week. I'm expecting the same thing to happen in components. And this was kind of an exercise in like, well, how can people come up with components to actually build? Top level thing here is think in terms of divs, not functions. When you're building components as a service, you're thinking about the end user experience and not the developer per se, right? The developer experience absolutely matters, but what you're selling is the actual end user experience. So there's 3 ways to do this that I've come up with at least. And I'm going to list them all, and then we're going to unpack them one by one. So first is just pick a common end user UI. Second, pick an uncommon UI that you feel like we need more of. And third, work backwards from APIs. So diving into the first, I'm going to grab some water. All right. So pick a common end user UI. I'm going to use Clerk as an example here, but I tried to pick one that was probably a little unexpected, and it looks a little like this. So this is Google's, I don't know what you call it, right? It's like, but it's in the top right. You click that button, screen pops up. We kind of looked around the web a lot, and this is Slack, kind of a similar thing. GitHub, similar thing. Stripe, similar thing. Netlify, similar thing. Twitter, Figma, Vercel. So everyone's kind of doing this thing. I don't know what to call it. We made it up, right? User button. I don't know. But like, we know you want this thing on your page, so why are we going to make you rebuild it, right? And that's kind of the mindset. And then the other thing that's fun about these is we go really far with it, right? It's just kind of the same thing I was talking about design, where like we get to just focus on little subtle animations that you don't get to focus on. We built in account switching. That thing at Google where you can sign into multiple accounts at once. Like, if you use Clerk, you get that. Just go to your dashboard and, like, toggle it on. You do have to pay us. Like, you got to go on a more expensive plan. But, like, it's just this fun exercise of, like, well, how can we just make it even better to just really build this moat of, like, you're never going to want to leave because we just have so much. And for you to build that yourself, like, how big is a company before they build account switching? It's like they're Google size. Cool. So that's the user button. Next strategy. So pick an uncommon UI we need more of. I'm stole an example here from Twitter. These guys launched last week. They have no idea I'm sharing this, and hopefully they appreciate it. But Doxly.dev launched, and it's Vercel comments as a service. So if you've seen like the Vercel preview pages, you can comment on them now. Someone was like, I want to do that and just like sell it to everyone, and they can populate in their own user data instead of people needing Vercel accounts. So that's Doxly. You know, I never thought of making a service for this, but someone really liked it, and they're like, oh, we should give that to everyone. Welcome, Doxly. I like this. This to me is like, when I say there's going to be hundreds of companies cropping up, it's like things like this that I can't even think of that I think really impressed me. Last strategy is work backwards from an API. I think this is actually a really reliable way of doing things. There are a lot of APIs out there, but they don't translate one-to-one to end-user UIs. I think it's actually more like working forwards. Like, what else do you need to add to a UI or to an API to turn it into a UI? First example that comes to mind here is like Stripe Charge API and Stripe Checkout. So if you think about Stripe Checkout, they have to layer in, I don't know, like the customers, the products, the prices, the countries, the taxes, and so on. That's a lot of extra work. It's like work forwards, I guess. But the other thing about checkout is like it doesn't actually capture everything. It's really good for like physical goods. It's really good for SaaS. But this company, Everfund, realized it's not that good for donations, and so they made a special component just for donations. Another one, like this was just me trying to brainstorm. Email API, like there's the notification settings, right? Like email doesn't feel like it has an end user component. You're just sending an email. But like a lot of people, if you go to the profile page, there's like, what are your notification settings? And turn on and off which things are you in. S3, Theo. You know, S3 is just not helpful, or very helpful, I'd say, for front-end developers, right? Like there's more to the full process of uploading. And so if you look at upload thing today, it's like they've also set up hooks for you. So it really does follow that theme in my head. And I didn't. Components coming soon. There you go. They have the hooks so far. But it's the same thing of like, how can we unlock the front-end developer to do things without the back-end developer? All right, so that's how to ideate. And then last thing is like, what do you actually need to build into this to make it a worthwhile component? This was like hard-fought lessons, or hard-learned lessons at Clerk. Must-have things to win the big sales. First things first, robust customization. This is really like stupidly hard to make your components customizable enough to get people to use them. The superpower we discovered was because in React we're not using iframes, the like sandbox isn't there. And a lot of embeddables of the past, right, like intercoms of the world, they look at the sandbox as like a feature, like, oh, like the developer styles aren't going to creep into my styles. Clerk, we take the complete opposite approach. Like, we do font inherit, right? Like, if you set a font on your body, like, we want that font to hit your component because chances are you want that font to hit the component. Like, we use rems a lot, so whatever your body font size is, like, we'll adjust the rems based on it. I think the mindset that we're in now is it's not so much can the developer drop something on the page that looks perfect right away. It's reducing the time between the developer dropping something on the page and it being styled how they want. And the way we set up our CSS classes today is it's like intentional that they can be polluted because it's not pollution, it's what the developer actually wants. That's like, there's a very layered story there. You really have to, you need like these CSS architects to really figure it out so that things flow the right way. It's also the C in CSS, right? The cascade that no one ever uses. We get to leverage it a little bit. And you never got to do that with iframes. So yeah, the other thing is bring your own classes. I didn't mention that. Like, people don't want, if you look at Stripe's customization for payment element, like, you need to learn a new styling strategy just to use payment element. Like, people would much rather pass in Tailwind classes. But you need that, you need the style to be able to break over the origin line. And the only way to do that is if you're mounting components directly in their DOM instead of in your own iframe. All right, the other essential feature is fallback to hooks. You can start with hooks, right? That's what upload thing did. But basically, this is just saying, like, at Clerk, we have the sign-in component, and then we also have the use sign-in hook. If that first one is about UI customization, this one's about UX customization. So really letting people design their own flows entirely. Hooks are the way to do that. It's basically a front-end facing API is the way I think about it today. The last thing that I mentioned here is fallback to REST APIs. We do still need these. I'd say it's like 1 in 100 ask for hooks, 1 in 1,000 ask for REST APIs. It's like tempting to say, oh, I want to ignore those. On the other hand, those tend to be the big ones. So you don't really want to ignore them, but like for fallback to REST APIs, it's things you can't expose to the front end directly. So things that would break your standard security principles, like programmatically signing people in is the example at Clerk. We can't just like let arbitrary sign-ins happen from the front end. So we do have a way to let arbitrary sign-ins happen with a secret key on the back end. And that's what I mean by fallback to REST APIs. that is everything I have. Thank you all. Thanks for coming out too. I'll be here downstairs at that big booth.
Nice job. Thank you.
Oh, yeah.
All right. Thank you, Colin. That was actually, I was a little worried he was going to be talking about SOAP APIs. How many of you have actually dealt with SOAP APIs? Yeah, they're not fun. And same thing with the iframes. I was like, yeah, I do not want to have to style an iframe. It is not a simple task. So that was really good. So next up, we have Sean Day Person joining us. Actually a fellow colleague of mine at Netflix. She will be giving an excellent talk, so come on up, Sean Day. Hey, good luck.
Good? Okay. Hey, hi. Normally they have some like upbeat music so I can show you my cool dance skills, but yeah, they told me to, okay, well, I guess I don't know what even to do with it. Like, what do you do to this? All right, guys, that was my best. Hi, everyone, I am Sean Day Person. I'm a senior software engineer at Netflix, and today we'll be talking about streaming server rendering. Hey, streaming server rendering with suspense. Table de toddler. Now, you may not be familiar with this term, and that's because I made it up. But you are familiar with the concept if you've ever gone out to eat with a young child. So parents, table de toddler is the term for when you're in a restaurant, asking for the meal for the child to be served first whenever it's ready, rather than everyone being served at their meals at the same time. Okay, so I see heads nodding. If you've ever gone out to eat with a young child, you get this. So my son is a little older now, he's 5, but when he was a little bit younger, anytime we would go out to eat, we would order in the style of table de toddler. And the reason is because if I didn't give him something to do or something to look at, he'd start sliding under the table or entertaining the couple behind us, and it would create a bad experience for everyone. So the point is that having our meals served to us separately actually enhanced our experience. We wanted our experience to be tailored to our unique custom needs. And when we talk about the server-side render architecture in React 18, the enhancements, parts of our front end can be served to us separately or asynchronously, just like the meals in a restaurant would be. And all of this is part of creating that custom-tailored experience that your users are looking for. But before we get into those enhancements, let's talk about a few definitions. So typically when you're thinking of an app in React, you're thinking of one that is client-side rendered or client-only rendered. And a client-side rendered app means that it's rendered by the client. So all of the instructions to run your app are held inside of a JavaScript script tag. When a browser receives a request for a page, the page sends the HTML, the CSS, and that JavaScript over to the browser to be parsed and run. Once it's parsed, your site is interactive. So videos will play, modals open, the whole nine. Now that's great, except if your user has slow internet connection, or if your app has large JavaScript bundle sizes like most apps these days do, it can take some time before that JavaScript is parsed and run. That means it takes some time before your app is visible for your users, never mind interactive. And until it's parsed, all your users will see is a blank page. So that's where server rendering comes in. And server rendering doesn't solve the problems of slow internet connections or large JavaScript bundle sizes, but what it does do is it gives your users something to look at while that JavaScript loads. So a typical app using server rendering works in this way. On the server, first we'll fetch the data for your entire application, and then also on the server, React will walk the component tree and render all of your components as HTML and send that over to the browser to be shown to the user. So already, server rendering is providing a better experience for your users because we haven't loaded the JavaScript yet, but your users are able to see some content on the page just as bare HTML. But keep in mind that server rendering on its own isn't enough for a complete website. Because yes, your users can see the content, but it's just HTML. It's not interactive. Right? Let's take the Netflix website, for example. Without JavaScript, you can't scroll through your list of movies. Movies wouldn't even play. So Netflix is essentially useless without JavaScript. So we want to move on to the next step, where on the client, we'll load the JavaScript for our entire application, and we'll attach that logic to the HTML already in the browser. This is called hydration. And from that point, your site is interactive. So you can go ahead and watch your Netflix movies. So you got that. That's server rendering in 4 easy steps. First, we fetch the data for your entire application. Then we render your entire application to HTML. Then we load the JavaScript for your entire application. And then we hydrate the entire application. So there's a reason why I'm emphasizing entire application at every stage of the process. And that's because, yes, server rendering is considered an optimization because your user can see something while that JavaScript loads, but it does have its problems. At least it did pre-React 18. And those problems all stem from the fact that at every stage in the server rendering process, we're forced to act for our entire app at the same time. And remember, just like the case is in a restaurant, sometimes having things served to us separately can actually enhance our experience. So here's our app, and this is an app pre-React 18. We have a layout, which is our outermost container component. We have a nav. That layout has 3 children, a nav bar, a sidebar, and a right pane. And then that right pane has 2 children, posts and comments. And in the browser, this is what it'll look like. So this is a pretty simple app. For the sake of our example, let's say that this comments component is our problem child. It's our troublemaker. Showing this component in the DOM requires expensive API calls for heavy amounts of data, and it also has a large JavaScript bundle size. So it's safe to say that at every stage in the server rendering process, comments is going to slow us down. But also note that comments is the most important part of our app, because this is the part of the app that the majority of our users are here to see and interact with. So we want to make sure that we do it justice. So let's talk about some of the problems that we'll encounter in this pre-React 18 app. So our first problem is that we have to fetch everything before we can show anything. So remember how server rendering is considered an optimization because your users can see that server-generated HTML in the DOM before that JavaScript loads? Well, we can't generate any of that HTML until we fetch the data for all of the components that are going to be rendered in the DOM. And remember that comments comes with expensive API calls for lots of data. So it's going to take some time for these data requests to be fulfilled. So at this point, we're faced with a choice. Now, we could, of course, just wait for the data request for comments to be fulfilled and then move on with the process of generating the HTML for the rest of the components. But that's not ideal because it puts your user right back in that situation where for several painful seconds or several painful minutes, they're staring at this blank screen while they wait for that server-generated HTML to come in. Another option would just be to leave comments out of the HTML that is rendered in the DOM. But this isn't ideal either for 2 reasons. First, remember, comments is the most important part of our app. So for the majority of users, a page like this is useless. Like they're not seeing the content that they came here for. And the second reason is that in order to make it a complete website, we will have to fetch the data for comments at some point. But rather than initiating that fetch from the server, now we have to initiate from the client and do that round trip from the client to the server and back. So this serves to elongate the process altogether. OK, so once we have that HTML rendered in the DOM, and this is what our HTML looks like, React will begin the process of hydration. Rather than creating new DOM nodes, React will walk the component tree and attach the event handlers with the HTML that's already in the DOM. So this process of attaching that logic to that server-generated HTML is called hydration. Once hydration is complete, your app is interactive. So again, you can watch your Netflix movies. So that brings us to our next problem, is that we have to load everything before we can hydrate anything, meaning that we cannot begin the process of hydration until we've loaded the JavaScript for all of the components that will be shown in the DOM. And remember that comments comes with this heavy JavaScript bundle size. So ideally, let's say this is our HTML again. Let's say that we've loaded the JavaScript for all of the other components. We've loaded it for the navbar. We've loaded it for the sidebar. We've loaded it for posts. Technically, theoretically, we should be able to hydrate at this point, but we can't because we have our troublemaker that's taking a long time to load. So again, we're faced with a choice. Of course, one option would be to wait for the JavaScript for comments to load, and then go ahead and hydrate the rest of the app. But that's not ideal for your user, because they can see the content on the screen, but they're clicking away, and they're not able to interact with it, not until it's hydrated. So your app is essentially frozen until then. And your user, again, is stuck for several seconds or minutes with content that they are no longer interested in or want to navigate away from. Another option would be to use code splitting to load the code for comments separately. But if we went that route, we wouldn't actually be able to include comments in the server-generated HTML. And that's because when React goes through the hydration process, it needs to be able to match the logic with the bit of HTML, a corresponding bit of HTML that's already in the DOM. Otherwise, it won't know what to do with that HTML, and it'll scrap it. And remember, comments is the most important part of our app. So again, seeing even an interactive page like this, for the typical user, is going to be pretty useless. We have a third problem, and that's that we have to hydrate everything before we can interact with anything. So let's say that your user is only interested in something in this sidebar piece, and they're clicking and clicking and clicking until all of the components in the DOM have been hydrated. Your app is not interactive. So again, your user is stuck for several seconds, even several minutes, until we've completed the hydration process for all of the components. And until then, your app is frozen. Now, all of these problems stem from a common thread, and that's that React, pre-React 18, assumes that everything is synchronous or needs to be done at once. And as we learned, just like when it comes to a restaurant, sometimes having everything at once doesn't create the best experience. React 18, though, gives us another option. Now we're able to split the work apart to create more efficiency. So now a slow component like comments doesn't prevent us from moving on with the process for the rest of our app. Our app can be served to us separately, table de toddler style. All of this is unlocked when you wrap a component in suspense. Now, suspense is a component that allows you to specify what you want to show your users until another component is ready. And suspense has been around in React for some time, but there are two major enhancements in React 18 that unlock this ability to break the work apart. And those are streaming HTML and selective hydration. Now, if you're just using React, there's a new API called Render to Pipeable Stream that enables these features for you. If you're using a React framework like Next.js or Gatsby, these changes are actually included under the hood for you. So let's talk about how they solve our problems that we outlined earlier. So here's our app again, and this is a React 18 and beyond app. Knowing that comments is a component that will slow us down at every stage in the process, we wrap comments in suspense. And then we specify a fallback, this loading spinner, that will show in place until comments is ready. And then let's go through all of our problems again. So remember, our first problem was that we needed to fetch everything before we could show anything. Okay? So by wrapping a component in suspense, you indicate to React, hey, this component within these suspense brackets is going to take some time. Don't wait up. Go ahead, render the rest of the app to HTML. I'll wait here. You just handle the user. And so React will walk the component tree and render the rest of the components to HTML and send that over to the browser for the user to see. In place of comments, we'll generate the HTML for that fallback, for that loading spinner in this case, and we'll send that in place of comments. And then this is what the user will see in their browser. So this is already providing a better experience because we haven't completed the fetch request for the data, for comments, but your user is able to see the majority of the app rendered as that bare HTML. And then in place of this very important component that the user is here to see, they see this loading spinner. And they know what to do with that. They know, OK, I'm not going to click around. I'm not going to click to another page. The content that I'm looking for is coming. I'm just going to wait. I'll give it a little time. Now, what happens when the data request for comments is fulfilled? Well, this is the fun part. React will generate the HTML for comments, in this case, that bit that is inside of suspense, and will replace the HTML for that fallback with the HTML for the comments. And then it will send it along to the same stream. This is called the streaming HTML part. Send it along the same stream over to the browser. And so this is what your user will see on the page. The loading spinner is replaced with the HTML rendered component. Okay? React, in addition to sending that HTML, sends a script tag that tells the browser exactly where comments needs to go so that it just doesn't end up wherever, it ends up in the right place, and the user is able to see their content. So we haven't even loaded the JavaScript yet, but your user is able to see that fully HTML rendered app. So we solved our first problem. Suspense also works the same way for our second problem, where we had to load everything before we could hydrate anything. Because by wrapping a component in suspense, you not only indicate to React, hey, move on with the process for streaming HTML, we want you to move on with the process when it comes to loading JavaScript and hydration as well. So now React can walk the component tree and load JavaScript and hydrate for all of the components outside of suspense. And then comments can take its sweet time and go ahead and load on its own separately and hydrate separately. This part is called the selective hydration. So we've solved our second problem as well. It works the same way for the third problem. Our third problem was that we needed to hydrate everything before we could interact with anything. So let's say that comments, it has JavaScript that's taking a long time to load. Or let's say that the JavaScript has loaded and it's taking some time to hydrate. If this was a pre-React 18 app, clicking anywhere on this app would do nothing. Your app is essentially frozen until the hydration process has been completed for all of the components in our app. But because we're in React 18 land now, your user can click, and even before hydration has been completed for all of the components, including our slow comments component, React is prepared, and your app is prepared to accept a click in the sidebar, for example. Now, I saved the best for last. In our example, we only had one component that had really heavy JavaScript bundle sizes or expensive API calls. But what if we had multiple components that looked like that? Well, we'd wrap multiple components in suspense. And so now React will go through the same server render process for all of the components. And then for the components wrapped in suspense, React will walk the component tree and run through the server-side render process in the order that they appear in the tree. So let's say, in this case, it's going to be the sidebars first. So let's say that React has begun the process of hydration for the sidebar, which is the first component in the tree, and your user comes along and clicks on the comments. What would happen? Well, React pauses the hydration of the sidebar because it recognizes that your user is interested in the comments piece. And it will prioritize the hydration of comments first so that it can accept the click, and the site becomes interactive. And then it will restart the hydration of the sidebar afterward. So not only are we running through the server-side render process asynchronously, but React is prioritizing the parts of the app that your user finds the most interesting. So you can imagine the benefits of selective hydration become essentially limitless as you start to adopt suspense more and more throughout your app and the boundaries become more granular. On the user side, it seems like your app is almost instantaneously interactive as the parts of the app that they're interested in interacting with become interactive the soonest. So we've solved our third problem. So previously, React assumed that everything was synchronous. Everything needed to be done at the same time. But React 18 gives us another option. And we use suspense to split the work apart to create more efficiency. And we can do this in a number of ways, as we've just seen. You, as the developer, don't have to worry about where things go or what order things show up in. All you have to do is specify what you want your users to see in the form of that fallback, like we had that loading spinner. And your users benefit from an app that seems much more performant and almost instantaneously interactive. Now go forth and create better user experiences at the edge of computer science and design with React 18. Thanks.
Break, right? Cool. Awesome. That was a really great talk, Sean Day. Well, hands up for Sean Day. Yeah. We are now headed to a break, so everyone can break and be back here at 7:15. So I'll see you all back here. Thank you.
you did so good. Thank you. Thank you. There were a couple times I just like lost my place.
at the same time. Can you perceive the way I lie to myself at night to keep you off of my mind? I had a dream I wasn't bound by things that keep me tethered down. At least I'm feeling something, but I'm not here when you're not around. watching you when you leave. Something new. Keep hoping you feel this too. Holding on and on and on and on. Hoping I can get to know you better. Living in sweet suburbia. Some fun is all we want. Two kids come alive in a night rush. I'll be the girl next door. You'll be my summer crush. Yeah, I think you should come and pick me up. 'Cause nothing feels as good as summer love. Move so fast. Here's hoping this night will last. Just let go. We're spinning with our eyes closed. Holding on and on and on and on. Hoping I can get to know you better. Living in sweet suburbia. Some fun is all we want. Two kids come alive in a night rush. I'll be the girl next door. You'll be my summer crush. Yeah, I think you should come and pick me up. 'Cause nothing feels as good as summer Two kids come alive in a night rush. I'll be the girl next door. You'll be my summer crush. Yeah, I think you should come and pick me up. 'Cause nothing feels as good as summer. Waiting on the edge of this moment, holding out for something golden. Found a light on a hill. I was waking up, looking for peace in a world that's divided. Gotta hold on tight when you find it. I was turning around, I was waking up. You're pulling me right in, rotate to you again. I'll live the rest of my life by your side. I wanna stay here forever, playing it all like the radio. Don't see how it could be better. All I know is don't let go. Stuck in a head rush about it. World's spinning fast, we're moving slow. I don't know how we found it, something supernatural. The space between us, feels like home. I feel like home wherever we go. The space between us is a place to rest your bones. It feels like home, it's supernatural. One look in your eyes and I find it. When you leave in my mind I rewind it. When you got it this good, you don't fight it. When you're with me, nothing else matters. On gray days, I live in your laughter. I collide with your heart, I'm seeing stars. keeping watch all that is storming. Waking up and turning on, keeping the light on, righting all the wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over the rest, it's coming. Crystal Jump into the deep end, give you all my weekends, taking all the back roads. We can make the time slow, betting on a feeling. We keep on reliving as the moon is rising. I will keep on finding. Jump into the deep end, give you all my weekends, taking all the back roads. We can make the time slow, betting on a feeling. We keep on reliving as the moon is rising. I will keep on finding.
hear more about.
Welcome back, everyone. I hope you all had a good break and were able to network a bit, get some food and drink. We have our next speaker, Jeff, joining us, which also he has some nice Jordans on, just kind of nice matching going on here. But yes, I will let Jeff take it away. Thank you.
Hello, hello, hello. Is this working? You hear me? Oh, okay. This is awesome. This is so exciting. I'm so happy to be here. Thank you, everyone, for coming. Okay, let's get into it. I'm Jeff. I am super happy to be here with you all today, and I'm going to talk a little bit about React server components. Before we get too deep into it, just a brief history about me, rewinding about 5 years of my career. I was at HashiCorp, starting a team at HashiCorp that built their public websites, so documentation, event sites, marketing sites. And that was kind of what originally got me into Next.js in the first place. HashiCorp was about 200 employees or so when I joined, and over my 4 years there, scaled up past 2,500 employees, which is crazy, and went public. And so scaling up very quickly and aggressively was a really important part of like how we needed to architect the apps there, because we knew that that was sort of the trajectory. And we ended up investing pretty heavily in Next.js and its architecture to help us with that. Last year, I made the jump over to Vercel, where I managed the Next.js team and its roadmap through the release and delivery of Next.js version 13. And now, as of literally yesterday, I'm working at Clerk. And so thank you so much to Ben. Thank you. Thank you all. And thank you to Ben for making the intro to me. It is entirely unrelated to this talk, but thrilled about it. Okay. A little extra context in case you didn't believe me. I have been in very deep on Next.js and React for many years, and thank you to Guillermo for the kind words here. All right, so let's start a little more zoomed out. I know that there's been tons of discourse on Twitter and YouTube and every platform, Blue Sky, et cetera, on the like very deep, specific technical aspects of React server components. But truth be told, I'm a pretty average developer. I've been an engineering manager for the last several years. And so I have a hard time keeping up with like super, super deep dives straight off the bat. And I prefer to start more broad to like build a foundation of understanding and then gradually like narrow into more specific things to help me build context. So if anyone else is an average developer like me, I'm sure none of you are, you're all exceptional, but anyone else watching, hopefully this will be a helpful approach. So in the following sections, we're going to step through all of the different React architectures from a high level. And I think it's important to note, and this is sort of like the central thesis of this talk, that React can be and often is used in multiple different ways that each have unique trade-offs. It's not simply one choice of just React. There are different ways that you can use it that behave dramatically differently. And so we'll step through existing architectures, and then we'll fit React server components into that same thought framework. We'll start with just diving into the original one. Most basic possible way to use React: put a script tag on a page, load up React, and use it. We've kind of gone through this all with Sean Day's talk before this, so I'm going to try to breeze through it really quickly. But this is what Create React App will spit out for you. SPA, single page app. The way that's typically used is you return a single HTML page. You set up some proxy, Nginx, something like that in front of your web server. You make it redirect every route back to serving the same page, and then the JavaScript loads in the browser, and it like reads the URL and then figures out what it wants to render on the page. And that might look something like this. Sorry if it's too small, but like regardless of the route, you get the same thing back every time. JavaScript's responsible for everything. So downsides, again, we've kind of walked through this, so I'm going to try to move through it quickly, but SEO is bad. Initial load is slow, no HTML comes out on the page, and so crawlers don't have anything to read, and they see a blank page. And since you require the HTML to be loaded, the JavaScript to be parsed, executed, and flush changes to the DOM. It takes a while for the first thing to actually show up. Cool. Next up, SSR. Also already talked about this, so I'm not going to go too deep into it, but effectively take the initial state on the server, render it to a string of HTML, send it through. This is great because it eliminates the downsides of client-only React in that you get HTML on the page. So crawlers can read it, search engines can read it, and the initial load time is faster in a way. Downsides here are effectively it's more complicated than client-only React, but that's a real serious downside. And I remember when this first came out, I remember seeing like blog posts about like Airbnb like doing server-rendered React and like Facebook doing server-rendered React, and it was like this big like inaccessible thing because it was so difficult to set up. And over time, frameworks like Next, Gatsby, Remix came out and made this all easier and more accessible for individual developers or smaller companies to use, which is cool. However, it is still more complicated, for sure. And here's my trigger warning. Sorry, I was a little late on the trigger warning. I'm sure that many of you have seen this type of error. This is sort of like why server-rendered React is sometimes more frustrating to deal with. This is just not a thing that could even possibly exist in client-only React. You would never see it. And figuring out how to deal with an error like this and fix it requires a pretty good understanding of like how hydration works, what hydration is, and that can be tough. So between these two cases, there is effectively a trade-off, right? In exchange for more complexity and more surface area for issues and errors, we get better performance benefits. So we can visualize it as something like a graph like we see here, where everything sits in a slightly different spot. And there's always people who'll tell you like server-rendered React is always better, or like server-rendered React's not worth it, and you should just do client-only React. But the truth is like everything in software engineering, it depends on the situation that you're talking about. For example, if you're running a small startup that has an app that needs to get off the ground quickly, and the app is a dashboard that lives behind a login entirely, the benefits of having great SEO and having fast initial load time are not really that strong because your whole app is behind a login, so SEO doesn't matter, and it's probably not going to cause customer churn if there's some fraction of a second lower before they see anything. In this case, your graph might shift a little bit, right? The same complexity is present for the architecture, but you get much less benefit from it, and so it might not be worth investing in. On the other hand, if you expect to make some dashboards public or make user profiles shareable, or if you're making something like a marketing page where the SEO benefits and the initial load time are super critical to its success, it changes the graph up in the other direction, where the benefits become much higher relative to the complexity. So doing a marketing page on pure client React is probably not that great of an idea. It's also worth noting that the complexity of an architecture is not like a hard set thing. It can change over time, and tools and frameworks can help to reduce complexity while retaining the same benefits, like we talked about a little bit earlier. And so frameworks like Next, Gatsby, Remix, et cetera, have effectively already, for server-rendered React, shifted this curve over to reduce the complexity and make it accessible to more people, which is great. So there's my thought framework. I hope this is helpful. Let us talk about where React Server Components sits on the spectrum, and I'll let you all speculate for a brief moment in case you want to verify your guess. I don't think it's going to be too hard. There it is. It's more complex. It offers more performance benefits. And I think, again, it's super important not to think about React as a single architecture choice, but as now 3 different architecture choices that you can make that all have different trade-offs depending on what type of app you're trying to build. So let's go back to profiling upsides and downsides in the way that we did for other things for React Server components. And so there's probably nothing too surprising here. The upsides effectively amount to what we've talked about already, which is better performance for more complex apps. However, this is a really important upside because the larger and more complex the apps, the more important the performance benefits are, because that's what scale is all about. Onto the downsides. Same kind of TLDR. The downside is largely it's more complicated, but we can get a little bit more specific on these things, and we will in a moment. For example, with client-only React, there was only one rendering environment, which is the client. With SSR React, we added a second rendering environment, which is client and server, right? Renders on the server, hydrates on the client. And with the React Server components, we add a third rendering environment, which is server only. There are a lot of implications to this. How does code behave in a server only environment? How is data passed between nested components that are in server only and not server only situations? We'll definitely dig into these in a moment. But also worth mentioning, if you are managing your own servers, RSC does more work on the server, and so the amount of maintenance and or infrastructure bills you might have could be higher, and this could be a downside for some teams, for sure. And then, of course, there's also the fact that this is all very new, and on top of that, it's taken a really long time to figure out with a lot of missteps along the way. I want to take a brief tangent into that, even though it's not totally relevant, because I think it's interesting. So RSC as an architecture was announced more than 2 years ago by Facebook/Meta and was sometimes called vaporware as a result of the long wait time between its announcement and its actual viability. The pattern was first adopted and released for public use by the framework Hydrogen, built by Shopify. Hydrogen ended up dropping React Server components, though, and their team was pretty open and honest about the reasons that this happened. I'm putting up just one quote tweet here, but there's a whole thread. It's interesting. I'll link to it in the notes later. But the short summary here is that implementing the RSC architecture was very difficult, of course, and several things needed to be implemented in exactly the right way alongside the base architecture in order to get things right. Nested routing, error handling, SEO metadata, and data loading were all things that kind of needed to work just the right way in order to make it work for users. Additionally, it needed a really tight collaboration with the React team itself, since the process of implementing the architecture turned up plenty of edge cases that required adjustments to React. The second publicly usable major framework release was through Next.js version 13. This was a super big release. At the time, I was managing the Next.js team, and it was definitely a proud moment for myself and for the team. I took this photo at Next.js Conf when it was being announced. However, the release was still definitely very beta. The concept of RSC was very far from being accepted by the community. It's a little bit farther along now, but it still has quite a ways to go. The only major framework implementation of RSC is still beta, and there have been lots of discussions and back and forth on Twitter, et cetera, about its complexities. With that said, let's get into some of the specific architectural differences, drilling down a little further. Mentioned a couple slides ago that RSC introduced a new rendering environment with server only. That alone is a really substantial mental shift in understanding, loosely equivalent to the shift between client-only React and server-rendered React, which was a huge shift that still not everyone has entirely accepted. But RSC adds more on top of that. It adds a dynamic in which server-only and client/server-rendered content can be nested and interleaved together. Let's get into some specific examples to clarify why that is such a huge increase in complexity. Start with the basics. Here you can see a client component nested inside of a server component. The server component is rendered only on the server and doesn't ship any JavaScript to the client. The client component is rendered on the server, but does ship its JavaScript to the client and hydrates. This works fine. So the natural next step is to think what happens if you flip this backwards. What if you have a client component that contains a server component? In theory, it should render the client component on the server and the client, and then inject a server component that only renders on the server. Unfortunately, the reality of this is that the import is converted into what's called a shared component, and it does hydrate and does execute on the client. That means if you're using anything like data fetching, it runs into the infinite data fetching problem that happens in the client, which we'll see in my weird live demo. And you could end up leaking server-only code or secrets into your client bundle. You can get a server component to render inside a client component with a separate pattern that I can demo in a minute by passing it in as a child, but there is certainly a lot more complexity to deal with here, and it's not always the most intuitive or straightforward thing. Really, this is just the beginning. I want to go through a series of Dan tweets. You might have seen these already. If so, I apologize. It feels like you have. But I want to just kind of talk through some of these examples because I thought these are really good examples of little edge cases that you wouldn't necessarily consider all of. So let's look at the first one. The premise here is that we have a client component that's wrapping a server component, and initially the server component is hidden by some state in the client. So you have a toggle that can go on and off, and when you turn on the toggle, the server component appears. So the question Dan's asking here is, when the user toggles the client component to have the server component show, is it already there and loaded and just appears, or does it get fetched from the server at the point that the toggle happens? You can see that there's also kind of like splits in the answers. And also, this is not like a right or wrong quiz. This is just something to think about in general. Let's move on to the next one. So in this case, the idea is that you've toggled the client component to show the server component, but then you have made an edit that changes the content of the server component, like mutates its data, and are asking it to refresh the route. In that case, the question is, do you reset the state of the wrapping client component when the data of the server component asks for the route to be refreshed? So would the server component then disappear and need to be toggled to appear again? And a second follow-up, now we have a client component wrapping a server component again, and a change is made to the client component that could possibly affect the contained server components, making the columns different widths. The question is, are they refetched from the server and re-rendered, or do they just stay the same? If you are an average developer like myself, thinking through these types of scenarios can kind of bend your brain into a pretzel. And this is a very real cost that has to be considered when you're thinking about dealing with React server components. So why go for it at all? You know, we already have server rendered React. This is crazy, right? The answer is this slide from before, effectively, and the TLDR here again, is that if you have a very large, complex app operating at high scale, these benefits are extremely strong and lead to substantially better performance that you could possibly achieve with non-RSC React. And that's often extremely worth it for businesses that are operating at scale. So now I want to do some live coding because I'm a masochist and I do it every time I talk. And it's never gone wrong, of course. We already saw some examples of streaming rendering and non-blocking data loading in Sean Day's talk before this, so I'm not going to go over those things again, but what I wanted to show off briefly is some examples of how data fetching and caching looks in Next. And I think an important note is that the caching behavior that I'm going to demonstrate is not a Next.js only thing, it's a React thing. So any other implementations of RSC will see the same kind of caching behavior. Let's do it. All right. Have we swapped? Ah, beautiful. Okay, so let me run you through what I've done. I have a page that fetches from a local API endpoint, and it takes the data and it renders it. And the local API endpoint that I've made makes a request to the Pokemon API, because Pokemon are great, and it fetches a random Pokemon from the API every time. And that's it. So let's see what it looks like. Here it is. Isn't that beautiful? Why is nobody clapping? There we go. So I'm going to refresh this page a couple times, and you can see the little thing bouncing in the top left. Every time I refresh this, nothing changes. What's the deal with that? You saw the API endpoint. Every time I was fetching a random one. So how come on this page, I get the same one every single time? The answer is because of the caching structure that's built into React. React provoked wide outrage in announcing that they had patched fetch. Whether or not I think that was valid outrage, I'm not going to get into. But they did, and they made it so that when you make this fetch, and whenever any other page makes the same fetch, it will cache the result for you as a default behavior. And that is often the right behavior to have as a default, because usually it's what you want. In this very specific case where I've purposely created an API endpoint that changes the result every time, it's not exactly what I want. But I can quickly adjust it by adding a cache option into fetch, which again is a React thing of no store. So let's see what happens when I change that. Look at that, it's already updated. And every time that I refresh, now I get a different Pokemon. However, I've also made another page that shows you the lamest Pokemon of all time. This page is, no one get offended, all right? It's random. This page is literally a copy-paste of the other page with one word changed, so showing off my above-average developer skills. And if I click over to that, you can see that I still have the same original one, and every time I refresh, it stays that way. And on top of that, when I click back to the greatest one, we don't get a refresh every time because we haven't asked the component to re-render. We've just changed the route. Kind of interesting. If I uncomment this here, then we get, after a refresh, a change every time. But again, when we change the routes, it doesn't make a fresh fetch every time the route is changed. Okay, running out of time. So the last thing I wanted to show here is what happens if you make this a client component, which some of you may have already experienced, but if you haven't, it's a wonderful thing of the world. So it works. However, if I open the network tab, you can see that we have a small problem called it's infinitely fetching it. I just think that this is special, you know? So I wanted to show it. That's the end of my demo. Okay, so let's wrap it up. I'm definitely almost out of time. So this is kind of like the grand thesis, but I want to go through a big, long set of caveats. You look skeptical. I hope I can make you feel better. If you're working with pages that don't need to load data or are loading data all at once from a single source, you probably won't be getting the most out of React Server Components upsides. It doesn't mean that it's not worth it to use it or you shouldn't use it. It does mean that you're paying a little bit higher of a complexity cost and not reaping your maximum benefit from it. I think that if you talk about over-engineered dev blogs, it's kind of a great similar example. These blogs are not over-engineered because they need to be, they're just blogs. They're over-engineered for developers to learn about new, interesting technology for themselves as an experiment. But if the stakes are high, if you're being paid to build for someone else, if you're making this decision for your company, you don't want to just spring for something that's cool and interesting because you want to learn from it. You need to make the right architecture choice. I think it's also worth noting that if you are on a team that's already using server components for a more complex app, and then you need to go create some marketing pages, I wouldn't say don't use React server components because it's overly complicated. You've already paid the complexity cost because you know how to use it. And you will reap some nice benefits from that, right? If you're shipping a marketing page that doesn't have a lot of interaction on it, you'll get a smaller bundle and a faster load by utilizing server components that are only rendered on the server. That being said, my general case here is RSC is primarily good for apps that are either currently quite complex and high scale or ones that are aiming to become that way. For example, a VC-funded startup app might not be that complex right now, but since it's venture-funded, the explicit goal for it is most likely for it to scale up and get big and complicated. And so you still need to consider that when you're making your choices, not just is it currently complicated, but is it planned to eventually become complicated? And if so, you probably would benefit a lot by looking into this. And of course, this is still early stages. Frameworks are always trying to drop the complexity curve down as well, and we're really just at the most early beginning phases. And so we can expect a lot of improvement to be coming down the line. So don't be discouraged if something doesn't work out like the crazy client, client loading waterfall. These things will be resolved and they will be better for sure in the future. That's all. Thank you so much for bearing with me through this. And I love you all. Thanks, man.
Right on. Nice work, Jeff. A live demo, too. Like,
Just wanted that
that's
to not
brave.
fall.
Next up, we actually have a panel. As you can see, chairs are getting set up. We have a panel talking about server component solutions from the community. Shruti will be leading the panel with Fred, Ryan, and Tanner. I've also been told that Shruti is going to be sharing a couple dev jokes. She is pretty infamous for some pretty good dev jokes, so hopefully I'm not overselling it, but I'm pretty sure she will land some good jokes to kick this off. So I will welcome our panelists up on stage. Sorry, Ben.
All right, before we start, I have some questions for the audience. So the way this works is I'll ask you a question. It's a dev joke. Just say the answer out loud. And if you guys know it too, you can say it too. So the first question is, what do you call an idle server? Rest server? Nice. A waiter. Okay. What do you call a busy waiter?
Did I hear service worker? That was a good answer.
Ooh. That's a good one.
That's good.
Server.
It's just server.
All right. Thank you so much, everybody, for sticking around and coming to our panel. We're going to be talking about server components, but from a community angle. My name is Shruti Kapoor. I'm a React 18 working group member. I am a front-end engineer at Slack, and I'm very excited to present this panel with some of our really cool people from the community, and I'm going to pass on the mic to Ben to introduce yourself.
Yeah. Hi, I'm Fred Schott, CEO of Astro. Just kidding. I'm actually Ben Holmes, a maintainer over at Astro. That is the unofficial CEO of Whiteboards as well. Good to see y'all.
I'm Ryan Carnietto. I'm the creator of Solid.js. I maintain open source, also Marco. Yeah, I guess I'll find out why I'm here.
I'm Tanner Lindsley. I'm a co-founder of Nozzle and creator of TanStack. And yeah, I'm also trying to figure out why I'm here.
Okay, so server components, or React server components, have become really popular since 2020. There's been a lot of buzz around it. I've been very excited to learn about it. I've watched all the YouTube videos. I read the blogs. I still kind of don't understand. So that's why I'm here, to understand from you guys. But before we get started, I want to ask you guys again, raise your hand if you are excited about server components and using them. Yeah. Yeah.
Can we split that question into two?
Okay. Raise your hand if you feel you know what you need to use to have server components in your app.
All the content creators raise their hand. All right.
There's an overlap, yeah.
Okay. Before we get started and talk deeply about server components, I want to take a minute to talk about how server components are different from server rendering. So Ben, here's a question for you. How are server components different from server rendering, and are they different from server rendering?
Yeah, I mean, they definitely are different in what they're able to do. Server rendering is what is kind of in the status quo going into like trying full stack frameworks like Next.js and pretty much all across every stack from Vue to Svelte to Solid, where things are kind of isomorphic, where you create something that is generally meant to be run on the client, and you also do a pass on the server in order to render out all the HTML that you want. So you send it to the client, they get a nice like first load without any JavaScript, you see the HTML and CSS straight away, and then you sort of load that component again, hydrate it into place, and then you're able to use it. You don't have to do the hydration step to do server rendering. That's typically how it's done. And with server components, these are now things that genuinely do not ship like an actual like full client bundle that retraces it top to bottom. There are some actuallys in there, but generally a server component is something that is going to run all the logic on the server. You can literally just like make a database call straight in the component, and you can plop it into what's being sent down the wire, not worried about leaking that server logic into your client bundle. So it creates this new dividing line to actually say which of these components are also going to run on the client, and if so, you can add a little directive in order to create a separate bundle for all of that stuff. So it's a way to really do server only.
I love that explanation. And I think it would also be very helpful to understand each of the libraries you guys are authoring and maybe one or two key features about it. So Ryan, maybe I'll start with you. Tell us a little bit about Solid.js and one or two key features.
Solid.js is a declarative reactive framework that doesn't use a virtual DOM. So I'd say one of the key features is something called signals. People may have heard of them, which is a reactive primitive that automates updates with other components. And INSO components run once. So you don't have to worry about stale closures and dependency arrays and use memo, use callback, use ref. Those just don't exist.
And Tanner,
Yeah, shout out to Signals. Let's go.
Wow. I have a library called TanStack Query that makes it so you don't have to write use effect. I have a router. Apparently, I have a form library now.
Just read the shirt.
Right here. Yeah, I have a lot of like small tools that I hope help the ecosystem out, and yeah, query and router, table, probably the three most popular ones. But yeah.
And Fred/Ben.
Just Ben. You can call me Ben. But yeah, Astro is an interesting one. It's been around for a couple years, and it's kind of like an OG look into the server-client divide, where you can create components that run on the server with an Astro syntax, and you're able to client hydrate any component framework, React, Vue, Svelte, Solid, Lit Element. There's integrations for all of them. So it's kind of this jack-of-all-trades way to do a server rendering approach, but it's all a multi-page app. It's all focused on content sites. It has a router that is kind of like the OG Next.js router. So if you're building those kinds of sites like marketing, blogs, e-commerce, documentation, Astro's a really good fit for that sort of thing.
Cool. And the way I understand is that server components has picked up a lot of buzz recently, but it's not a new pattern. So Ben, I'll start with you and tell us a little bit about the history of server components, but also what do server components mean to you?
Yeah. Ooh, that sounds, yeah. What do they mean to me?
What do they mean to you?
What do they mean? We're getting philosophical. So, wait, what was the first question?
What was the first question? Tell us a bit of history about server components.
History, that's what it was.
Get excited about the
Yeah. I was focusing on the second one. But the history is an interesting one. I actually got the chance to chat with Dan, other creators in the React core team, just everyone really, to understand like where did this come from? Because I've heard about server components since like 2018, it feels like. We've always been building up to it like concurrent mode. I don't know when I heard about that, but I was in college at the time. But it was a winding road. What was that?
Concurrent mode was 2018. Server components
2018.
was 2020, yeah.
2020. Okay. The historian.
Yes.
Waiting for him to talk about Marco. We will get there.
We will.
But,
Don't bring it
sorry,
up
I
yet.
stole the
Don't
thunder.
bring it up.
Shouldn't have done it. But I know it started from like, because Facebook was originally a more PHP stack. They actually had something called XHP, which was like a more fancy way of being able to start from a server rendered template and being able to render JavaScript components or sort of compartmentalize parts of UI and be able to ship those in separate bundles. And all of that was kind of, I mean, it's in the PHP world. It's definitely a different landscape. You're crossing a language boundary there from PHP to JavaScript. And then React came along and kind of just blew that pattern away, and we had server rendering, and everything was assumed to run on the client, and it owned your app bundle. So now coming back to server components, it's taking that old mantra that Facebook was kind of working on there, and it's pushing it into a full JavaScript context. So now you have server components written with JSX that can then turn into client components down the tree, also rendered with JSX. So it's a consistent way to write server logic and client logic all using JSX in tow. So it was a very gradual sort of journey that was born out of what Facebook was doing for the past decade or so.
Yeah, Facebook is my view on server components might be a little bit more broader in the sense that when I talk about server components, I don't just talk about React. And while it's not necessarily the same thing, you can see a lot of these technologies over time leading to us to where we are today. So if you want any kind of validation on the fact of whether these are something you should look into or invest in, I definitely suggest you do. And that's because, as you mentioned, XHP and Facebook's time doing this way back, the technology like BigPipe in 2010, this ability to kind of stream in the assets and do everything in this partial way. I worked at eBay for a bit, and this is where the Marco part comes in, because you got to talk about that. We were very influenced by what Facebook was doing with BigPipe, and similarly at Google, they were also influenced. Basically, these large companies had the same problems they had to solve. They saw the JavaScript bundle increase before anyone else did, and we're talking 2011. People didn't even realize the implications yet of what bringing all the JavaScript to the client would do. But what they did know is they had real businesses that had real performance needs. So they had to attack this problem. And in my mind, server components is kind of an evolution of this trend through do partial hydration. You might have heard things like islands. I get to actually introduce it here. At eBay, they introduced islands and out-of-order streaming sometime around, I think, 2013, 2014 time period. And that's how eBay.com works. And no one's heard of Marco, but it was a JavaScript framework that is open source. You can go literally download on NPM, that introduced this kind of technology approach, but to basically no one caring. I can't sugarcoat that at all. And over time, it took many years later, I'd say also around 2020, when we saw other frameworks kind of start picking up on this island or partial hydration story. Astro, Fresh, which is just the idea that you have these defined boundaries like Ben introduced before. But so in a sense, when you look at server components, a different way of looking at it, perhaps, is taking this idea of islands, these interactive components, and bringing back client-side routing. Because the one thing that every solution before React server components had in common was in order to benefit from this less JavaScript, you had to actually do full-page reloads. It was a multi-page app. That was the trade-off. In order to know something couldn't get to the browser, well, it could never render in the browser, which meant client-side routing was out of the picture. So from that perspective, I know I'm getting a little long-winded here, a different perspective is server components is almost a return to our roots of just doing this MPA rendering, except we've added back the client-side routing.
Tanner, anything you want to add?
Yeah, can you repeat the question?
A bit of history about server components and what do they mean to you?
I don't know a lot of the history of server components, to be honest. All this is news to me, and it's great to get a history lesson, and I'm glad that I know where this stuff came from. And yeah, Marco did it first, right?
As with most things.
Right. No, for me, I look at server components I try to look at server components from more of a practical, pragmatic approach. And just right now, I'm really excited about them, and it's really interesting to see the technical implications of what it's going to unlock. The islands architecture with the SPA router, and when you get into situations that would suffer from these very specific types of performance issues, the fact that you can do this is just amazing. that we figured out how to do this at all, right? So honestly, hats off to anybody who's worked on any server component architecture, because it's crazy to put all these moving pieces together and to figure it out. But to me personally, right now they mostly just mean, an excitement on the outlook of React. And honestly, any framework, including Solid or whoever else wants to implement them, I think they're exciting. But right here in this moment, like it's difficult for me to reach out and say, yeah, I can take this server component hammer and see all these nails. I don't really see that right now. I don't see the nails. Right. But I'm excited because I know that as long as we keep working on the server component ecosystem and the architecture, and everybody, kind of like Theo's talk this morning, everybody kind of pitches in, not just in React, but like across the entire ecosystem, that story's going to get better, and the nails are going to start popping up.
Yeah, love that.
So yeah.
That's actually a really good point. So I'm curious, how are you thinking about server components, and how are you thinking of adopting them within each of the libraries? And maybe Tanner, I'll start with you.
Yeah, I can start. The first place that server components really would have a significant impact on the stuff that I'm working on is I have a router. It's new, it's in beta, and I would have probably already have launched it. But server components are definitely making a splash, and the hype is real. Literally everything at this conference has had some overtone and undertone of server components. So I decided to kind of hold off and just kind of see what was going to happen. Is it going to be a really quick adoption? Is it going to be difficult to implement? And me personally, I've already run into a lot of challenges trying to just understand what I would need to do as a library author to absorb all of the features and the contracts and all the things that I need to provide a server component experience to my users. So there's a few hats for me to wear. As I'm an excited user, but I'm also a library maintainer, and I'm chomping at the bit to kind of get my hands on the polished outcome of all the efforts that Next.js and the React team, they're working together, trying to get server component architecture really, really good. And I hope that maybe out the other end, they can just kind of pop out this little checklist, that's like, hey, we figured it out, all of it, and this is exactly how you can do it, and we'll help you along the way. And I know that we have the working group, and there's lots of people exploring on stream on how to do this kind of stuff. I really can't wait for all that just to come together and become something more actionable.
Okay. Oh yeah. Okay. It seems interesting challenge because routing is like the backbone of our frameworks, and server components in this direction is definitely lent towards that question of do you need a framework to use React? And as a kind of independent, I can definitely see where that gets challenging because you're like, I have a router, do I need to be a framework? And if I'm a framework, do I need to support server components? So that's challenging. It's also challenging on the outside, right? Because as I said, I was working on a lot of these kind of optimizations, and then when I understood what server components were, they fit into my mental model of an extension of what we'd been seeing with islands. I knew immediately I wanted them, but it's been challenging. Last fall, before we released the beta of Solid Start, that's in our ecosystem, our next competitor, we decided to put together a demo where we had, basically we took something similar to Astro's Islands, mixed them with a client-side nested router, and then added mutations that did in a single flight. I know I'm getting a little technical, and we basically came up with a kind of a server component prototype. We put under an experimental flag, and honestly, I was blown away. It wasn't myself who did a lot of that work. It was people from our community, Ryan Turnquist and Nikhil Seraph. They put this demo together, and I opened the app, and I played with it for a moment, and I was like, yeah, this is a single-page app. You could not convince me otherwise. And then I opened the network tab, and I saw there was no JavaScript there, and I was just like, what? I started doing an adrenaline rush. Whenever they came up with a new demo, I'd be like, okay, I'm not going to open the network tab. I'm just going to test the app as much as I can, put it through all the paces, and then I'd be like, And this is because I'm a performance junkie, so like this is how I get my rush. It's like, oh, Lighthouse, you know. So yeah, I'm very excited. The challenge I had is React's a big, powerful ecosystem with a lot of influence. I had to solve a lot of these tools. Like I was doing it before use client or use server was a thing. So we had to design other patterns. You know, we played around with like, I don't know, calling functions with $signs on the end and like a bunch of other things, but effectively the same patterns in the end. And I think that's the biggest thing. It's challenging being a small player trying to figure out how to consolidate on APIs when you're going to get overridden by the larger player anyways. So like this is kind of consideration. I could release the thing, you know, last fall and been like, look, we've got the full server component solution right here. But I got to, unfortunately where I'm sitting, I got to wait and see what Next does. So yeah, you know, whenever the big announcement comes out, and well, I think it might be this week, we'll be ready.
Nice. Astro is definitely an interesting one with server components, since we already kind of have like the server component setup, where Astro files are the server-side logic and templating that you use, and then you can resume with client directives with all the islands that you want to insert. So when it comes to React server components, like first off, I think there's things that Astro can learn from React server components approach, specifically around like how they handle client-side routing, where like Astro's more in the sort of older wheelhouse of like treating things as multi-page apps, which is a really nice default. It leads to zero JavaScript and doesn't assume you want a router tied around everything that you're trying to serve on your website. Like if you're trying to serve an RSS feed, you don't need that included in your SPA. So it was a nice default, and we're trying to like look at how React Server Components treats client routing to see what could be done there, like with out-of-order streaming, which is how they approach the problem, which is sort of it's a novel way that they've actually set it up. So I'm interested to learn more about that. And also, like, whether React Server Components can just be supported in Astro directly. Since we already support React, it does make sense. If the React ecosystem grows around React Server Components, libraries are really built on the idea of like, yeah, we provide all these async first components that are designed to run on your server. At that point, like if we want the React community to really like thrive inside of Astro, it makes sense to also support React Server Components in some way, where you can start from an Astro page, insert React Server Component trees wherever you want, and you kind of get the best of all worlds there. So I think that part is more of a wait and see, and how it can be implemented inside of Vite, which is our bundler of choice and Solid's bundler of choice, and see where we can go. And yeah, we're all Vite lovers up
Yeah,
here.
Vite is amazing.
We love Vite. Yeah, still waiting on Vite reaction. Yeah, shout out to Vite. Can we have some claps for Vite out there? Let's go. Yeah. We get some boos for Webpack. Okay, I won't do that.
We've made good progress there. You'll be happy to know.
Yeah, Nikhil.
Nikhil Saraf has been
working
working on a Vite RSC plugin, which has a lot of the functionality that we find in some of the frameworks. So I anticipate in the coming weeks we're going to see more projects in Vite. And also Daishi has been building a framework around React Server Components. So there's a lot of really cool options starting to pop up.
Yeah, that's good to know.
So actually, that's a really good point, because I'm thinking as somebody who is using Astro in their app, as a developer who's using Astro in the app, when Astro does start using React Server Components, not React Server Components, Server Components, how does that change the code that I write as a developer who's using Astro? And same with TanStack, how are you even envisioning the code will change for the developer who's using the libraries?
Like how it would change if you were starting from like
let's say I have an Astro app or TanStack, and the library has adopted React Server Components or Server Components. How does that change the code that I write? Or do you think it's going to be done behind the hood?
Because I feel like with Astro, it would mostly just be like interop with React Server Component libraries and being able to use that, because Astro already has like the server first model in order to insert islands. Right. So I feel like if you're using like the Astro syntax in that way, I feel like you'll continue using it that way, and then also plop in React Server Components if you're porting them in from some other library or source. Also, like if you're an MDX author and you just want to like write your content, insert components wherever you want to, it might be convenient to go from like MDX to React Server Components. That's something Astro does quite well right now, where we have like you can insert islands into MDX just like you do in Astro files. So being able to do that with React server components would be cool as well. But the mental model of like server first is already kind of baked into how Astro does things.
Right.
So it'd really just be like a different flavor or template syntax for the same thing that you're trying to get out of it.
Right. Tanner, what do you envision?
I don't know, like, I think we've seen what it looks like in Next, right? With their new app directory and their alpha production, I don't know which it is, server components feature in the app directory.
Right.
And it's cool to go in and see kind of how the code does change. It doesn't change too much from what you would expect. You see some async, some await sprinkled around, and of course, use client and use server.
Yeah.
There's not really a whole lot of other changes, but more just around the way that you can approach writing your applications. My hope is that and I'm a little more constrained than like Solid or Astro because I'm not running on top of my own framework. I'm kind of locked into whatever React decides is the way it needs to work. But the hope is that it would look very similar to this experience that you have in like the app directory from Next, right? And obviously not the same conventions or opinions around application structure or routing or things like that. But at the core of it, you would essentially have the same capabilities: async, await, use client, use server, and then on top of that, maybe even some extra fun stuff like we've been working on Bling, which is kind of an experimental code extraction utility that we have talked about could potentially also satisfy the same contracts that server components need to function. So think of it as a potential alternative syntax to server components, and we'll see what comes out of that.
Cool. Ryan, anything you want to add?
Yeah, I mean, it's an interesting challenge. I keep on empathizing with Tanner's position here because you've got these large, even, we talked about CSR apps, but even SSR apps, and now you're kind of like, okay, how do I move to this new world when it's the core of the paradigm that's flipped? Like, before we were like, okay, everything runs on both sides, annotate what runs on the server. And now we're like, no. Most things run on the server, annotate what runs on both sides. This is an interesting migration because the easiest thing is just like scorched earth, just throw away the old thing, make a new directory. But like it has to beg the question, like, is it possible to not do that? Like, is it possible to put both things together? Like, I want to solve that problem in general. I'm hoping there's a way we can work with React to solve that problem as well. It always takes the first step to kind of go out and go like prove something's doable, but I think we need to do a little bit more right now to get to where people are today. So, because I don't think it's necessarily I've seen people positioning server components as a complexity thing, and mechanically it's complex, but that complexity should not be pushed onto the end user, at least ideally, because what we are seeing here, in my opinion, is kind of a rebirth, a third generation where we started on the server with our MPA apps, then we went client side. Sure, we server rendered them, but they're still single page apps. Let's not kid ourselves. Now we are kind of in this new paradigm. This is a big change and a big step. So it's a very exciting one. How do we get people from point A to point B? That's what I want to see.
I just want to echo that like coming from the perspective of like maintaining a relatively large single page application that is fully client rendered, like going back to Jeff's talk that was just right up here, like I am the only client rendered dot on that chart, and for the exact reasons that he brought up, right? Just because of the nature of our product, like it doesn't make sense for us to be, in a server rendered environment. But that doesn't mean that there aren't features and things that we could do with a server rendered environment on, some specific places of our application that would be really fun and beneficial to our users. It just means that a bulk of our application lives there. And, for me, looking at, okay, this move to server components, right now, I don't really see any other way other than kind of what Ryan said, where it just kind of scorched earth, like you got to just rewrite, right? And you have to approach it from the top down. It's a completely new paradigm. But like for a lot of like I did this exercise at my last talk that I did, but raise your hand if you maintain an SPA. Okay. How many, keep your hand up if you server render that SPA. Okay. 2. There were a lot of hands up for just single, like just client-side SPAs. And there you go. There you go. So I don't see a smooth migration experience where if we just kind of say, hey, there's all of these applications that are SPAs that are kind of like they're stuck there. They're not stuck there because that's what they're choosing. It's because they're probably successful applications and they have customers and clients and users, and it's probably just a non-starter to say, you know what, here's this new paradigm, you got to start over. Yeah. That's just a non-starter for a lot of companies, and not because the developers would choose that, but because their superiors probably would never approve it, right? Yeah. I'm really interested in exploring this middle ground of like, is it possible to run an SPA, router and RSC router in parallel, and maybe switch off between them and offer some type of migration story, because that's where I'm at. And it's a non-starter for me. I'm not going to go rewrite Nozzle to use RSCs when, like, the benefits just don't make sense for me. But if there was that incremental migration path, I might consider trying it out and moving smaller pieces and eventually getting over that threshold.
Yeah. Ben, was there anything you wanted to add?
I mean, not really. I would definitely echo that, because I know at my last company, that was one of the spas that was not proudly a spa. There was a bit of lighthouse issues there where everything was client rendered, and well, they were kind of stuck on it because it was hard to migrate from one infrastructure to like a server rendered one or an opinionated meta framework. Like, there are a lot of people who work just outside of that whole opinionated piece of it and just like spin their own React router, or literally using the React router library or TanStack or whatever, and just roll their own. And trying to get off of that into now a very new paradigm is a bit different. So part of me is fascinated with like server components like in core Vite, or just something that's like not tied to meta framework opinions about routing in other pieces, and if that can ease that migration, like from full on like client rendered to full on server rendered.
Yeah, we're talking about what Nikhil is working on, right?
Yeah, exactly.
Yeah. The wheels are in motion.
The wheels are in motion.
We're not just sitting here saying, wow, wouldn't it be great if there was a migration story? Like,
Stuff's
like
progressing.
we're trying, like we've got irons in the fire trying to if it's not going to be provided or talked about, I realize the next team and the React team are very busy. I don't expect them to just show up with the migration story on a silver platter for us. So we're trying to be in control of our own destiny a little bit and just create that migration story.
So server components are part of the plan for your future.
Definitely.
Yeah.
Cool. Okay, so let's talk about why server components may not be a good fit for an app developer, and maybe some challenges of server components. And Ben, I'll start with you.
Yeah, I've definitely heard some interesting takes on like, is there an inflection point where server components, at some point, like so much is client rendered that it's like everything is one big use client island. It's come up in Astro before, possibly because there's more limitations around client routing in Astro that server components addresses. But I have seen like, new libraries like TRPC that allow you to do calls from server client and back again. Those are definitely built around dynamic experiences that are client first. And server components are like a different way in order to bring that data into the client, and it's just a different pattern. That can be suitable to some apps and not others. I can't speak to specific ones because I don't build highly dynamic apps. I build mostly content sites. It's why I work at Astro. But I have seen from those kinds of library maintainers that is more of a thing. And also those that rely heavily on React context-based tools. That's like a big thing I'm seeing in the ecosystem, where it's like, your error monitors and your CMSs and all of your tools rely on React context, bubbling things down from global state. And in server components, you don't have like a full client context wrapping everything. There are server contexts and other ideas floating around there, but it's a paradigm shift that might be worth it when libraries move over to those new patterns, but in the interim, it is sort of a challenge to like sort of move that needle from client context and global state and management over to server side. And you have to judge whether that wait time and that technical cost is worth it to your team.
Oh, gosh.
Yeah,
Go, Tanner.
You know, I really just can fall back to like what I know. And really quickly, I'll describe to you Nozzle, the project that I work on all day. It's 100% behind an authentication gate, so nobody uses it without logging in. And we use Firebase, and even though they came out with a new version, we're talking about at least 1 second to see anything at all. And once you get in there, yeah, we have admin sections, and it's a lot of REST and CRUD and managing data. But then the kind of big part of our application that gets used a lot is this big dashboard data exploration area. And like there is very few sections of this area that have less than 5 or 6 widgets or charts on the page or tables of some form. Yeah. And each one of those widgets is producing a unique query that is being sent off to our API that is then crawling terabytes of data out of BigQuery. And I'll go back and bring it all back in and show some data for you, right? And all that can all change just with a few clicks. The entire screen can just change. And thinking about how I would replicate this experience in React Server Components just sounds like a nightmare. Like I don't know how or why I would actually want to try and perform the same type of actions and get the same user experience that I have right now using server components. Now, that's not the same story for maybe some other places of our application, right? But those places are just very few and far between. But I realize that's because that's the nature of the application that I'm working on, right? Now, I realize that if you were, if you're building an e-commerce solution, you're probably going to want amazing SEO. You're going to want things to be really fast. It's going to be heavily personalized, right? And you want to avoid all of the waterfalls that you can. That to me just seems like a really complex problem where maybe server components could really shine there, and maybe that makes sense why Next.js and Vercel, like they're pursuing server components so heavily, because they probably have a lot of clients that have those problems, So I'm honestly just not the best person to ask about how server components can help you, because I don't have a product that I believe would benefit from them right now. But I plan on building more products in my lifetime, and I guarantee some of them are going to need these types of features.
Yeah, it's interesting because like when you look at the spectrum of apps, the holotypes, and you can like lay them out, like you have very heavy content stuff on one side and then maybe Figma on the other side, and you can go through the spectrum. To me, server components represent the widest range we've ever had a single solution cover on that. Not necessarily saying that it can do everything, but it's for the first time, like classically something like React or a client-side framework was kind of in the middle going over to the Figma side. Like you can build like really interactive apps with it, don't really bring it into e-commerce kind of thing. Now we're kind of getting to a point where like they've extended it out into that content area where it basically could be good in places that care about fast page loads. But I mean, there is still that question, like this paradigm, everything we've seen so far with it is kind of a return in the same way to the MPA mentality. Like it's a simplification. This is how you balance the complexity. When you update stuff, you do kind of mirror like forum posts. It's kind of like a full page reload. That's the mentality behind it. If you have the idea is you could, by doing so, you can move a lot of the complexity out of the client. So now you don't need all that client-side state. We've seen this as a part of a progression over several years, right? We started from a place, and this came up in Theo's talk, where we're like, okay, here's React, and then you're like, how the hell do I manage state? And it's like, okay, we need something, Flux, Redux. Then it was like, okay, then we got GraphQL, and then we realized that we could like literally do everything and coordinate it. And like, even when it's far as something like Relay, and you're just like, wow, like to this day, I just look at Relay as this thing of beauty that like everyone could aspire to. But the truth of the matter is, there's a complexity there that was too hard for a lot of the average developers who weren't necessarily building these crazy apps. And as a framework like React gets more and more popular, it's going to be used in a wider range, right? So what ended up happening is we actually ended up realizing we didn't need as much state management if we did in data, and then we realized we didn't want to deal with the caches, so we just got like simpler, and we were like, okay, well, screw that normalized cache, let's just use React Query. And then we were like, okay, even to a certain degree, maybe React Query is too much, let's just use remix loaders. And we just kind of like, server components are almost at the end of that spectrum where we're just like, yeah, like, let's just don't do anything on the client, you know? Like, I mean, I wish things are that simple, but nothing here stops you from using this model as a base to build those complex client stuff. It's resetting that baseline. So it's compelling because like from a, I don't know what you call it, first principles, like from a theoretical standpoint, we can look at the solution and be like, yeah, this covers all the boxes. But it's always tricky because you might be better served to go to a solution that caters to you. So that's where the balance is going to be fit. Because right now we're just showing like, look, you can do all this, and this is a really simple case. Like it fits perfectly into those monolithic frameworks. But we still got this kind of divide between the classic client model and server components that we need to kind of get over this hump. It's like there's two Reacts. There's like the old React and this new React that's wrapping the old React.
Yeah.
That's a good way to put it.
I think one of my worries as somebody who's still on the old-ish React is, at least React 17, is like when React does become new and in my enterprise, like will my code break if React server components are introduced to the code base? So yeah, that's a question I'll pose for you guys is, will my existing tools and libraries work when server components are introduced? I'll start with Astro first.
Like, will they work when they're...
When server components are introduced to Astro, would my code still work? Not React code, Astro code.
Yes. I mean, yeah, like, I mean, I kind of, as I mentioned before, like it should work the same way.
Right.
And it's really just unlocking like a new sort of syntax in order to use those existing island patterns. So I feel like, at least compared to the other two frameworks up here, Astro is like kind of the easier answer of like, we don't have to have users buy into a new mental model of thinking about things server versus client.
Right.
So it does make it easier to sort of step into that world if you want to. And React also has like some opinions around client routing and use transition in order to like, you know, choose which parts are going to refresh and having nice loading states. And the nice thing about Astro is it's kind of bring your own router, where we are working on like a client-side routing primitive in the next release, which is super exciting. But if you don't opt into that, you can just sort of make a wildcard route and say, all of these routes on my server, on my static build, whatever, are served by this React bundle. And it is a React server component, potentially, that's able to manage the router from there. And you can sort of say, sort of sanction off, like this is the React server component app in my Astro application, and then all these other routes are served by Astro files or Markdown or XML if you're making an RSS feed. Like it's very flexible in that way where you can like opt out of all the switches and just kind of use React server components as they're intended.
Yeah. No, I mean, I'm going to answer for both, I guess, React and Sol on this. I don't think it's going to break your existing code, but the challenge is the change in emphasis means that 50% of the existing ecosystem just doesn't matter anymore, which is a bold claim. But it's kind of true from my perspective. It can still exist, but to much diminished means, which is a very interesting challenge because it means that, yeah, you can do what you're doing for as long as you're going to do it, but maybe people stop supporting it as much as they kind of move on to their different and new patterns. I think it's also very interesting for new players in here because one of the biggest benefits of using React is its ecosystem. If half of it, you know, so I think it's interesting. We're going to see where this goes. This is why Theo's talk is for us to kind of move into this next thing. It's going to take support of the community to build these new libraries that fit this paradigm.
Yeah, like if you can do it on the server and it's within reach and easy to do, like think about how much of the React ecosystem has been built around fetching data, right? So Don't stop using React Query just yet. But it's true. Like they were just going to see more and more growth into, oh yeah, you can just do that on the server, right? But at least for now, the time being, like I don't think that things are going to break. You know, most of the time, all it takes is a well-placed to use client to make sure that things are going to keep operating normally. So I don't think that I don't think existing tools are necessarily just going to, you know, just totally bust and break right now. They need to keep working to get us through, or however many of us are going to be able to move over to using server components. They need to keep working through that transition period and into, you know, the next few years at the very least, right? Like I said, people aren't just going to be able to rewrite their applications overnight. So we're talking about a large process, years, right? I mean, think about how long it took for class components to seemingly go away and then...
or AngularJS.
Or Angular.
To Angular.
Oh!
Did I say that?
Or knockout.
So no, and that's how it's been designed, right? The React team it has always been really, really great about backwards compatibility, and the fact that they've been able to, you know, move on server components and introduce all this new stuff, and the only thing we have to do is like, oh, you got to put a use client in there sometimes. Like, that's pretty dang good. We need to, you know, hats off to the React team, because that's hard to do.
Yeah, I remember seeing a screen cap of like just taking a class-based component, putting use client, and just using it with like brand new React 18, and it works totally fine. So it's like, oh man. So if you're porting over something that's already like client-based or server rendered, like it can just kind of go in there. And server components are the layer on top that can like sort of, you know, import and wrap around it. As you were kind of mentioning, it's like new React on top of React.
Yep.
That's pretty neat. I think we have time to take maybe 1 or 2 questions from the audience, if there are any questions. Ask us the spicy ones. Go for it. Theo.
So we've talked a lot about the friction for the adoption here. I am curious how we could frame this. We touched on it a bit here against previous adoption. Like when we first used React, we had to do a rewrite anyways. Like that's part of how this works. I think that hooks was a one-off in that sense, where hooks was one of the few times we didn't have to rewrite everything to get something. I'm curious, like, how big does the difference have to be for y'all to consider the rewrite, and how much do you think people are going to be moving in that direction in contrast to when we moved off of whatever we used before to React in the first place?
I think a lot of that has to do with frameworks, because, like, if you have, you know, a small to medium or even a large app, like, and you're considering rewriting right now, like the only choice you have is to use Next, right? And you want to use a framework. You want something that's going to hold your hand through the process, and you want the support and the ecosystem around that framework so that you feel safe in your decision, right? But right now, like, there are so many applications that don't, you know, have the capability to move to a new framework, or let alone a new host, or even have a host, like a server at all, right? So I think, obviously, having more frameworks, having more options for developers to try them out without having to commit to so much in one go, I think that's probably going to play an important role.
Sure, but now React was a new framework, or should we just treat this like it's switching to a new framework?
Yeah.
Replacing React so that something else doesn't.
Yeah. Okay. I mean.
Yeah. If this is a completely new framework, then I mean, isn't this the point where people consider switching to other frameworks as well? Like, not okay.
I don't think. I don't think it's as big of a move, but it is tricky because I find like it's easier for people to take an existing app. This is my experience with Solid, at least. It's easier for us to go like, okay, let's take our React app and put some Solid components in the like the leaves, so to speak, at the end. You're like, okay, I want to do this thing optimally. I'll just like put it at the bottom. Vue with Vue Vapor is actually taking this approach as well. You can use Vue, and then you can use their new compiler fancy thing, like in the leaf nodes. But it's a bigger ask to swap out the root of your application. And I've been seeing some frameworks trying to like position like, look, you can use your React stuff inside our framework. That's a harder sell on the migration. I think that's the problem, the challenge here is because with server components, that is exactly it. It's like you have to you can't just like incrementally adopt it the leaves. You actually have to like take the root out and then move the pieces in. I actually, to a certain degree, that's doable because you get to keep those pieces and then shrink them in size over time. But that direction is actually a much more longer, painful process than doing it the other way where you attack it and then kind of go up. So I think that's where the challenge is. It's not quite as hard as completely switching frameworks, but it
But almost.
But I mean, people are coming to me these days. I'm just
I can tell you personally, like it does feel like I would be moving to a new framework because you are. It's a paradigm shift. There's syntax changes. There's new environments. There's new execution models. There's so much new stuff that it does feel like a new framework, and that's not a bad thing, right? Because at least it's a good spiritual successor to what we have, Angular. But like with Angular, I felt very lost when I was, in Angular 1X land, and Angular 2 is like kind of looming around for years. I didn't know what to do, and that's when I switched to React. Right. So it can either be a really great opportunity for React to say, hey, we know it's not, for the ecosystem to say, yeah, we know it's kind of a big process to move, but let's make it as easy as possible. I don't know what those tools are, but they need to exist, or like the pain could potentially drive people away from gaining the benefits, right?
Ben, did you want to add something?
Yeah, I mean, I remember the original question was around at what point is the benefits worth the trade-off of it is when you can compare struggles of would it be hard to move React to Svelte versus create React app to Next? I don't know. It depends on the app. It really depends on how much you would have to uproot. My last company, we were struggling to go from create React app to a file-based routing system, mostly because the incremental adoption was so hard. Because you're going from less opinions to a lot more opinions. And React Server components as they exist today, they are built around the app directory and other things as it exists right now. So if the benefits aren't super strong, you're building something highly dynamic and it's okay, I could uproot the routing system and do something completely different, might not be worth the trade-off. But if you're going from almost no SEO presence and no server rendering to full server rendering, SEO managed for you, routes are actually easier for developers to understand, so the friction is worth it for onboarding junior devs, all these other reasons, then suddenly the trade-off is really worth it. And you can bring your React design system along for the ride, which is usually something that might be weighing down larger systems. So yeah, it's really when you're in that pocket of content stuff, e-commerce, and anything that really benefits from the server side.
Yeah. Cool. I think that's all the questions we can take. And because we are over time, I want to say thank you so much, folks, for joining us. Brian, panel.
The panel. This is an amazing panel. That's it for the talks tonight, but there is mingling and everything, networking downstairs. There's some table topics that you can join and talk with. I can't remember all the table topics are, but join the topics. There's these massive flags that you will see on what the topic is. Join them, listen in, contribute, whatever it is, and catch up with some of our speakers. Thank you all for attending, and hopefully see you tomorrow as well. Thank you.